Good morning, all of you. Today we are going to start our third chapter, that is coordinate geometry. So, first we are going to see what is a Cartesian system. You have studied the number line in the chapter on number systems. On the number line, distances from a fixed point are marked in equal units positively in one direction and negatively in the other. The point from which the distances are marked is called the origin. We use the number line to represent the numbers by marking points on a line at equal distances. If 1 unit distance represents the number 1, then 3 unit distance represents the number 3, 0 being at the origin. The point in the positive direction at a distance r from the origin represents the number r. The point in the negative direction at a distance r from the origin represents the number minus r. Locations of different numbers on the number line are shown in figure 3.5. See, here the distance between any consecutive numbers is 1 unit distance, and here they have marked the origin. Also, between 2 and 3, 1 unit distance they have marked, that is between any two positive numbers there is a 1 unit distance. Similarly, between any two negative numbers also there is a 1 unit distance. This is the number line. You have already seen it, and you know how to mark numbers on the number line. So Descartes invented the idea of placing two such lines perpendicular to each other on a plane and locating points on the plane by referring them to these lines. The perpendicular lines may be in any direction, such as in figure 3.6. But when we choose these two lines to locate a point in a plane in this chapter, one line will be horizontal and the other line will be vertical. Okay, that is as in this figure 3.6. See, one line is horizontal and one line is vertical. So that will be used to denote the Cartesian space, a Cartesian plane. So these lines are actually obtained as follows. Take two number lines, calling them x dash x and y dash y. Place x dash x horizontal as shown in the figure, and write the numbers on it just as written on the number line. We do the same thing with y dash y, except that y dash y is vertical, not horizontal. It is clearly given in the figure. You can take your textbook and refer your textbook for more clear picture. Now consider both these lines in such a way that the two lines cross each other at their zeros, that is at the origin. The horizontal line x dash x is called the x-axis and the vertical line y dash y is called the y-axis. Okay, that is clearly plotted on the figure. Now the point where x dash x and y dash y cross is called the origin. That is, these two lines intersect at the origin and is denoted by O. Since the positive numbers lie on the directions OX and OY, OX and OY are called the positive directions of the x-axis and y-axis respectively. Similarly, OX dash and OY dash are called the negative directions of the x-axis and the y-axis respectively, because negative numbers appears on the left side of the x-axis and on the downside of the y-axis. So these are the negative directions of x-axis and y-axis respectively. And since the positive numbers appears on the right side of the x-axis and the top side of the y-axis, those directions OX and OY are called the positive directions of the x-axis and the y-axis. You observe that the axis axis is the plural of the word axis. Divide the plane into 4 parts. Okay, you can see the axis divide the plane into 4 parts. These 4 parts are called the quadrants. 1/4 part numbered 1, 2, 3 and 4 anti-clockwise from OX. Anti-clockwise means the direction opposite to the direction in which the handle of a clock moves. Okay. So the plane consists of the axis and these quadrants, that is quadrant 1, quadrant 2, quadrant 3, quadrant 4 and the axis, that is x-axis and y-axis. We call the plane the Cartesian plane or the coordinate plane or the xy plane. The axes are called the coordinate axis. Okay. So this is what we call it as a Cartesian plane, or we can call it as a coordinate plane, or we can call it as a xy plane, and these axes x-axis and y-axis are called the coordinate axis. Understood? So these two lines will divide the plane into 4 parts, 4 equal parts, and these parts are called quadrants, and we mark it as quadrant 1, quadrant 2, quadrant 3, quadrant 4, that is anti-clockwise direction from the direction of OX. Okay. So now let us see why this system is so basic to mathematics and how is it useful. How it is useful. Consider the following diagram where the axes are drawn on the graph paper. Let us see the distances of the points P and Q from the axis. Okay, we want to find the point P and Q. We want to find the distances, okay, from the axis, x-axis and y-axis. So for this, we draw perpendiculars PM on the x-axis and PN on the y-axis. We are drawing perpendiculars on the x-axis and y-axis, and we are naming it as PM and PN. So for consider the point P and draw perpendiculars to x-axis and y-axis PM and PN. Similarly, we draw perpendiculars QR and QS as shown in figure 3.10. Okay. You find that the perpendicular distance of the point P from the x-axis, perpendicular distance of the point P from the y-axis measured along the positive directions of the x-axis is Pn, and that is equal to OM, and that is equal to 4 units. Okay, first we are finding the length of Pn, and length of Pn is equal to length of OM, and length of OM is 4 units. So you got length of PN is 4 units, and that will be the x coordinate. Now the perpendicular distance of the point P from the x-axis measured along the positive direction of the y-axis is PM, and PM is equal to what? ON, and ON is 3 units. So you got the measurement of PM as 3 units, and this will be the y coordinate. Okay. So, similarly, consider the point Q and the perpendicular distance of the point Q from the y-axis measured along the negative direction of the x-axis, that is OR, and it is same as SQ, which is equal to 6 units. Similarly, you can find the perpendicular distance of the point Q from the x-axis measured along the negative direction of the y-axis, and that is OS, which is equal to RQ, that is equal to 2 units. Now using these distances, how can we describe the points so that there is no confusion? So we write the coordinates of a point using the following conventions. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis, positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. So for the point P it is plus 4 and for Q it is minus 6. Therefore the x coordinate is also called the abscissa. Okay, x coordinate is also called abscissa. Now the y coordinate of a point is its perpendicular distance from the x axis measured along the y axis. Positive along the positive direction of the y axis and negative along the negative direction of the y axis. For the point P it is plus 3 and for the point Q it is minus 2. The y coordinate is also called the ordinate. Okay, x coordinate is called abscissa and y coordinate is called ordinate. In stating the coordinates of a point in the coordinate plane, the x coordinate comes first and then the y coordinate. We place the coordinates in brackets. Okay, that is the method of writing the coordinates. So first we will write the x coordinate, then we will write the y coordinate within a bracket. That is the method of writing the coordinate. Hence the coordinates of P are 4, 3 and the coordinates of Q are -6, -2. Pair, ordered pair, we will write it in a pair enclosed in brackets. Note that the coordinates describe a point in the plane uniquely. 3, 4 is not the same as 4, 3. So for plotting a point uniquely in the plane, we use coordinates to denote that point, and in that coordinate, first coordinate will be the x coordinate and the second value will be the y coordinate. So the point 3, 4 is not the same as 4, 3. Both are two different points, okay. The point for the point 3, 4, the x coordinate is 3 and y coordinate is 4. But for the point 4, 3, x coordinate is 4 and y coordinate is 3. So both are different.